experiments need to be conducted with predetermined constants of variables to ensure accurate outcomes. And there's a fairly specific emphasis on this throughout the unit, and which I'll get to a bit later. And hypotheses are able to be proved and disproved with accurate experimentation. The VALS level 4, so grade 5 and 6 science links, tell us that students explain change in terms of cause and effect. They identify characteristics of physical and chemical changes. They identify and compare the properties of the new or changed materials with those of the original materials. Identify and explain the relationships that exist within and between food chains in the environment. Describe the relevance of science to their own and other people's lives. And design their own simple experiments to collect data and draw conclusions, all of which are hopefully relevant to this unit. Okay, so the unit topic is why are microorganisms so important? And I kind of used a combination of Kath Murdoch's, can't remember the name of it, but Kath Murdoch's inquiry model and the E5 inquiry model. And the part that I took out of Kath Murdoch's is this specifically here. It tells us that you should have a broad question as the unit topic, and then underneath that you should give students the opportunity, ideally, to form generative questions, which are questions that are going to form more questions, so they're not easily answered just with kind of, they're not closed questions in other words. So the generative questions that I've come up with are, what are microorganisms, where do they live, and how do they affect us? And yeah, as I said before, the inquiry approach is the E5 model, which is kind of promoted by the Department of Education, particularly in relation to science teaching. So lesson 1 is the Microorganisms Unit Introduction, which is the Diagnostic Assessment. Each lesson is actually broken into 2 main parts, which I'll show you in a sec. So the first lesson is to show students microorganism images and ask generative questions. So for example, the images that I would show them are things like cheese, compost heaps, yogurt, bread, those sorts of things. And then after that, give them 2 sheets of paper, and on 1 sheet of paper ask them to write down all the facts that they know that are relating to microorganisms, and this would form the diagnostic assessment of the unit. And on another sheet of paper, write down as many questions relating to microorganisms as they can think of. And then I would have those on a highly visible place in the classroom. So for example, something like up here, or on a corkboard or something like that. The second part of the first lesson moves on to the explore phase. And in this phase, we would set up the mould experiment, which I might just leave for a bit, and I'll go into a bit later because that's part of the activity that I'll be doing. So I'll go on to explain the rest of the unit. Lesson 2 is a yeast experiment, which I actually did. I felt like I learned a lot actually doing this unit, which was pretty cool. And I documented it all as well. So the yeast experiment is to determine the effects that temperature has on yeast. So you don't actually bake bread or anything like that. Well, I did, but you don't have to. The point of the experiment is to make 4 dough balls and leave them in various conditions and see what happens to the yeast or to the dough in those conditions. So this is just a recipe pretty much for bread dough and how to make the dough. And the observations that I found were that pretty much, it's interesting that they're all stretched. So these are the 4 dough balls as they were when I made them. And then, that's them in the bowls. And then this was after 1.5 hours. So you can see the dough ball that was in the freezer didn't change at all. The one that was in the refrigerator only slightly puffed up. The one in both the 2 at the top there puffed up about the same amount, but the one on the right that was in the oven formed a bit of a shell, and as I was kind of looking at it, I didn't realise until I kind of punched a bit of a hole in the shell, so you can kind of see the creases there. And then it's more evident after 3 hours that the room temperature one is the one that's going to grow the most. The one that was in the oven stayed the same. And it was actually kind of hard with the oven one because the oven temperature, it says the lowest temperature on my oven is 50 degrees, but I put it a bit lower, so I'm not entirely sure. So you would need a thermometer and things like that to make it accurate, but obviously I didn't have one. So that's the yeast experiment. Let's go back to the presentation. So with that experiment, you would involve the children as much as possible and get them to make observations that are clear in terms of measurements and things like that, so that they're no longer kind of using vague scientific terms. They're being quite specific about exactly what's happening. So the amount of time, exactly. Actually, another thing that I would change about that experiment is the bowls that I put the dough balls in, because it made it difficult to measure exactly how wide they were because they were inside those bowls. So perhaps I would leave them on a flat tray and just put them straight on top, so you could really easily hover a ruler or something like that over the top of it. And then the second part of lesson 2 would be to record the results of the mould experiment so far. So the teacher would retrieve the bread samples from wherever they are. Again, I'll go into this in a sec. Okay, so the mould experiment is that I took, 2 separate types of bread, so pita bread and white rolls, and set the bread up so that it was all, first of all put them in plastic bags that are zip-locked, and the emphasis needs to be on safety with this, because some people are allergic to moulds, and there are some moulds that are toxic, although I don't think bread moulds are too toxic. But again, you don't really want to be opening them and puffing them around and stuff like that. So I set the moulds up. Initially I had really no idea on the conditions that I should be setting them up in, and I was a little bit panicked as well because I started the Thursday before the assignment was due. And so I set them up in the following conditions. So the breads marked A were in a dark warm place. The breads marked B were in a dark warm place also, but they'd been run under a tap just for a few seconds. So all the ones in this column here were all run under the tap for a few seconds. So C and D were in a light warm place, E and F were refrigerated, and G was in a dark warm place. Sorry, G and H were in a dark warm place, but I'd wiped the bread on a dusty shelf because I read somewhere on the internet that this is a way to make mould grow quickly. And it turns out that it is, because the H sample, which was the one that had been run underneath water, was the first one to grow. And it grew quite differently to all the others. It grew in a kind of, it almost looked like a pizza when it started to grow. I'll show you the pictures. So you can see here, on day 1, you can see there's just, it's kind of difficult to see, but there's just a little bit of dust here, which is where the dust was from when I wiped it on the shelf. Day 4, again, it's kind of hard to tell, but there was just a little bit of pink mould starting to appear. And by day 7, it was really well and truly starting to look quite disgusting. Yeah. And again, by day 9. Since the other ones have caught up, although not quite as, even if you compare sample A and sample H, you can see that the colours are pretty much restricted to green on this one, greeny blue, whereas this one's, yeah, it still looks kind of quite multicoloured. So, when I mentioned earlier that the emphasis is on constants and variables, I've made sure that all the bread are all in the same bag size. The pita bread is all facing up, so that just in case for some reason the underside was more susceptible to growing mould. They're all of equal size, and I've tried to make it all as even as possible. And the only variables are the variables that I mentioned a minute ago. And the reason also that I used white rolls and pita bread were to, well, one, because I was hoping that one would grow faster than the other, but also to demonstrate that the presence of preservatives. So you can see with sample C that mould has just started to grow on this just in the last day or two, whereas with the white roll there's no mould on it at all yet. So that's kind of good. But what I'll get you guys to do today is to draw a label diagram of the mould, and we're going to look specifically, ideally I would have a microscope of some sort, particularly a microscope that would link up to the whiteboard, but I don't, so we're just going to have to use a label diagram that I found on the net. But I'll hand out an A4 sheet of paper and some coloured textures and pencils and stuff. And on the A4 sheet of paper, I'll get you guys to have a look at one of the mouldier bread samples and draw a diagram, and then in that diagram draw a close-up section. So, for example, you might kind of draw a piece of pita bread like that, and then maybe a kind of something like this, and in here we'll draw a more kind of close-up of exactly what mould looks like when you zoom in on it. And also underneath, if you could just write a sentence or two, or a couple of sentences about the size of the mould in relation to the size of the bread. It's kind of difficult to measure because, well, some of them are almost entirely mould, whereas others have kind of got bits and pieces of mould in them. But if you could sort of say the mould is taking up roughly, I would probably estimate this at about 20% of the bread. And also mention the colours and also perhaps the textures that the mould is appearing in. So I'll hand out sheets of paper.
Can I just, sorry James, I don't mean to normally interrupt while we're doing it, but I just want to have a couple of comments here because it is reasonably critical. Please make sure the bags stay closed.
Yeah.
Because in fact some of these are not moulds necessarily. Some of them to me look like bacterial growth.
Oh really?
Salmonella. You've created life.
Yeah, well, my girlfriend wasn't very happy about having these mouldy old bits of bread all over the house. But
no, as long as it's sealed up, it's okay. But it's usually just as a bit of extra sort of sciencey knowledge, if you like. It's pretty unusual to get moulds, some of those yellowy colours, some of the colours.
Okay.
And also, normally bacteria when it grows tend to be,
now we all want to
bacterial cultures tend to be round.
And so what do we do?
So the green one, the green stuff is definitely bread mould. This one's been wiped on a shelf. That's the shelf one, isn't it?
So you've just got salmonella on your shelf and just put it on that.
Well, no, it won't be somewhere like that. But
yeah, I don't know.
What about D?
probably, you know.
Yeah, that one.
D, I don't know.
Into a liquid.
D, it was actually bright red. It looked like it had tomato sauce on it initially when the mould or whatever it is bloomed.
Was that bread?
Yeah.
Yeah.
Well,
Put in some see if it melts.
it's probable with that one. In fact, that was a wet one, right?
Yeah.
Wet.
Yep.
And you hold the bread in your hand under the tap.
Yep.
This probably had things come up your head.
Okay.
So that's stuff that's grown from just the trace of whatever it was on your hands.
Okay.
You have dirty hands.
Everybody's got dirty hands. Yeah.
Yeah, it's pretty interesting actually.
It is extraordinary.
Okay, so I'll show you all the mould diagram. This is what mould looks like up close. So I had a bit of a look at exactly what moulds were, and they're kind of like mini mushrooms, basically. So this part here is called the sporangium, and that's where the spores come out of. And the sporangia 4 is like the stem of the, well, almost, if you were to compare it to a mushroom, it's like the stem of a mushroom.
It is exactly that. Yeah.
Yep.
And the better mushroom that you eat is the sporangium.
Right. Rhizoids are basically the roots, so you won't be able to see them. Well, you won't be able to see them, unfortunately, but if we had a microscope, you wouldn't be able to see them. The stolon is the connecting fibres that connect each head. And in some of the bread samples that are here, you'll be able to see systems that, particularly on some of these more well-developed ones, where the mould has kind of left the bread and it's starting to kind of attach itself to the bag. Kind of there. They've been, I travelled with them this morning, so they're a bit crushed. But, and they're called Mycelium. So that's the kind of structure overall of how the mould all joins together. So if you could draw something similar to this in the kind of circles. So ideally what you would do is do this activity on throughout the lessons, and then you would form a chart on the wall somewhere where you would compare each of the days to each other. So you would have all the A's in a line here, and maybe sample A written down here, and then day 1 to whatever, however many days apart you do them, so that the students can see the comparison between the days. Back to the presentation. Okay, so lesson 4. So this is the elaborate part of the inquiry unit. So students would first of all come up with a rubric. So this task is going to be used for a formative assessment at the end of the unit. So they would work
Summative.
Summative, not formative. They would work in small groups to create posters, and they would research a topic, not limited to, but something probably like one of these topics. So compost heaps, cheese, penicillin, milk or yogurt. And they would research the history, uses, scientific elements, diagrams and process details. So they would probably need at least a couple of hours, I would think, maybe even staggered over a couple of lessons to do this task. And because they've come up with the rubric as a class together, they're clear on what the expectations are, and it gives them that sense of ownership over the assessment. In lesson 5, they would present their microorganism uses posters to the rest of the class. So the teacher marks according to the class created rubric. And then finally, to tie up the unit, they would have a question answering session, which would be part of the evaluate section as well. So they would review and answer any remaining questions. And sorry, actually, I haven't emphasised that throughout the unit, in their science journals, they should be continually reviewing and answering and forming new questions wherever they arise. And I found actually that I had quite a few questions even forming just in my own head, because I'd never really intentionally grown mould before, and I had no idea of what the conditions. I knew that mould preferred kind of dark places and that sort of thing, but I wasn't exactly sure of how long it would take to grow. You know, what the different species of mould were, if there were even different species, if some were toxic, if they're not. You know, there's a lot of questions you can get out of these activities. So it's important that the students throughout the unit are given time to answer their own questions, share knowledge, perhaps in the form of group discussions and things like that, and also form new questions, which they'd all record in their science journals. And then at the very end of the unit, the teacher would collect science journals and grade them according to a rubric that I've created for, that perhaps even the teacher would give to them at the start of the unit before they start creating their science journals, with things specifically relating to observations, diagrams, thoroughness, presentation and spelling. Obviously it's adaptable to whatever you would want to do, but something like that. And also I've created this 5-lesson inquiry unit, but I think the original intention was for Sev to add some of her activities and incorporate them into the unit. So it would probably go longer than 5 lessons, and that was my original intention, but unfortunately that hadn't happened. But that's pretty much it. So.